So hello friends, in today's video we are going to discuss about the stimulated emission. So stimulated emission is a very important event which happens in the EDFA, Erbium Dopped Fiber amplifier. So in amplification process, stimulated emission is a very important event which helps to amplification the incident light. So we need to know in details about the stimulated emission, and in today's video we will discuss about stimulated emission in details. Let's see. First of all, we just need to know about the atomic orbital structure. So you can see here, this is the atomic orbital structure. This is the nucleus, and these are the different energy states which are away from the nucleus. So you can see here, the energy of an electron orbiting an atom nucleus is larger for orbits further from the nucleus of an atom. However, quantum mechanical effects force electrons to take on discrete position in orbitals. So there are discrete position, you can say the discrete energy level in which the electron moves around the nucleus. When an electron absorbs energy, either it from light, either it from heat, it receives the incident quantum of energy and uh, it moves from their energy state to the higher energy state. But these transitions are only allowed between discrete energy level. It means when these N1 electrons have received some external energy, it can move to N2, N3 or N4. It means it can move only to the discrete energy levels. You can see here these are electrons moving around the nucleus. So when an electron is an excited state from a lower to a higher energy level, it is unlikely for it to stay for the way forever. It means when the electron is moving from lower energy state to the higher energy state by absorbing some external energy, it does not going to stay at the higher energy level forever. It just coming down to the lower energy level after emitting some different photons. When such an electron decay without external influences emitted a photon that is called the spontaneous emission. Means when the electrons moving from higher energy level to the lower energy level without interaction of any external photons with the excited state electrons, then this process is called the spontaneous emission. And in the contrast of that, when the electrons coming down to the lower energy level by influence of any external photons or signals, this is called the stimulated emissions. In stimulated emission, an incoming photon interacts with an excited atom or molecules, causing it to transit to a lower energy state. So this is the stimulated emission. Means the emission is stimulated by some external resource, or you can say the external photons or the incident light signals. During the process, the incoming photon stimulates the emission of a second photon, and that second photon is in energy, phase, and direction with the original photons. Stimulated emission is a fundamental process behind laser where photons are amplified coherently. You can see here, this is the energy level, this is distance from the nucleus, these are the discrete energy levels of the electrons. You can say atoms in the excited state. Here, the atom in the ground state, you can see even is the ground state, E2 is the excited state. And whenever the photon which is generated from E2 to E1, it releases the energy of delta E, which is equal to h nu naught, whereas the Planck constant and nu naught is the linear frequency, angular frequency, you can say. So here is the before emission, the electron is in the higher state, or you can say the excited state. During emission, you can see that this incident, or sorry, this is the electrons in the excited state interact with the incident photon, you can say the incident photon, and then after emission this incident photons generates another photon which is in similar energy, phase, and direction. So this is the stimulated emission, and this is very important in amplification process. So let's in details. Here again you can see this is the energy difference between E2 and E1. During emission, incident photon is interact with the electrons in the excited state and generates one more photon, which is in the same uh, direction, phase, and energy with the incident photon. and thus you can say this is amplifier. In the same way, there are number of incident photons which is interact with the different electrons in the higher energy state, and thus there is a lot of photon is generated and the light is amplified. So here you can see the concept of population inversion. You can see the atoms in the ground state, here the atoms in the excited state. So you can see the N2 is the number of electrons in the excited state, and N1 is the number of electrons in the ground state. Here you can see the N2 is greater than N1, and this is the condition for the population inversion. Stimulated emission is the process by which an incoming photon of a specific frequency can interact with an excited atomic electron or other excited molecular state, causing it to drop to a lower energy level. So this liberated energy transfer to the electromagnetic field, creating a new photon, which is very similar in frequency, polarization, and direction to travel that are all identical to the photons of the incident wave. Stimulated emission take place when the excited electrons interact with the another photons. You can say the incident, this is the incident photon, and when this incident photon is interact with any photons in the excited state, then stimulated emission happens. Stimulated emission can provide a physical mechanism for optical amplification. If an external source of energy, suppose when we are using any pump, and this external source of energy stimulates more than of 50% of atom in the ground state to the transition into the excited state, then this is called the population inversion. It means when we are uh, giving the external energy source in the form of pump to the erbium ion, and here the 50 more than 50% of the electron is moving, transiting from the ground state to the higher state, then this situation is called the population inversion. So this is all about the stimulated emission. Thanks for watching.